All right, welcome. Today, we are going on a quest to decode what's really going on in your first Java course. And look, let's forget about those dry, boring textbooks for a minute. Think of this as an adventure into the world of coding, and I'm going to be your guide.
Okay, so here's our game plan. This is the map for our journey today. We're going to start with the basics, your Java quest. Then we'll get into thinking in objects, inheriting some superpowers. Yeah, really. We'll talk about conquering code chaos, juggling multiple tasks, and finally what skills you'll have at the end of all this. Let's get into it.
You know, every great quest has to start somewhere, right? And for us, it starts with understanding the lay of the land. Our world, for today, is Java. This language is, well, it's everywhere. It powers a huge chunk of our digital lives. So the big question is, what is it, really?
So what really makes Java special, what gives it its power, is this one core promise. Write once, run anywhere. Now what does that actually mean? It means you can write your code on, say, a Windows machine, and it'll run on a Mac, on a Linux server, anywhere, without changing it. And the secret sauce behind this is something called the Java Virtual Machine, the JVM. It's kind of like this magic translator that lets Java run on pretty much everything, from huge web apps all the way down to the Android apps on your phone.
Okay, you're going to see these buzzwords a lot. Simple, object-oriented, robust. But here's the thing you gotta know. These aren't just empty marketing words. Seriously, you should think of them as the DNA of Java. They're the core principles it was built on. We're actually going to dive deep into a couple of these today, especially object-oriented and multi-threaded, because that's where you start to see the real power of Java.
All right, let's get to the next level. This is the first big power-up you're going to unlock. And it's a totally different way of thinking. Seriously, it's a mindset shift. You're going to go from just writing down a list of instructions to actually building little worlds inside your computer. It's all about learning to see your code as a bunch of objects that talk to each other. And this slide, right here, this is the aha moment for so many people learning to code. The old way, it's like a recipe. First add flour, second add sugar, third mix, just a list of steps. But the object-oriented way is completely different. It's like building a virtual world. You're not just writing steps anymore, you're creating a whole system of interacting parts. You're making the car, the driver, the road, and they all have their own jobs to do. It's a game changer.
So how does that even work? Well, this blueprint and house analogy is honestly the best way to get it. A class is the blueprint. It's the design. It has all the plans, where the doors go, how many windows, all that stuff. But you can't live in a blueprint, right? An object, on the other hand, is the actual house. It's the real thing you build from that blueprint. And the cool part is, from one single blueprint, you can build as many houses, as many objects as you want.
And here's what that looks like in actual code. See that? Class box. That's our blueprint. Everything inside those curly braces defines what a box is. It doesn't represent one specific box out there in the world. It's the template that says every single box we ever create is going to have a width, a height, and a depth. From this one simple blueprint, our program can now create thousands, even millions of unique box objects.
Okay, so you've learned how to make blueprints. Awesome. Now for the next big trick. Inheriting superpowers. And I'm not really kidding. This is all about being smart and efficient. It's about not having to reinvent the wheel every single time you want to build something new.
The best way to think about this is like family traits, Imagine you have a general blueprint for a car. It's got 4 wheels, an engine, seats, the basics. Well, now you want to make a sports car. Instead of starting from scratch, you can have the sports car inherit everything from the regular car class. So it automatically gets the wheels and the engine, and then you just add its own unique superpowers, like a turbo or a cool spoiler. You get all that base stuff for free.
And this is exactly how you build really complex things in a super clean, organized way. Here's the playbook. You start with a really general idea, like a shape. And you say, okay, every shape can be drawn and every shape can be erased. Then you create more specific versions, like circle, triangle, and square. They all inherit the ability to be drawn and erased, but each one does it in its own special way. It's just really elegant and powerful.
All right, every hero's journey has bumps in the road, and coding is no different. Sooner or later, things are going to go wrong. In programming, we call these unexpected problems exceptions, and they can totally crash your program. So your next skill is learning how to deal with them, how to anticipate the chaos and stay in control.
So here's the big idea. What happens if your program asks for a number, but the user types hello? Or what if it tries to open a file that just isn't there? Without exception handling, your program just crashes. Boom, it's gone. But Java gives you a really powerful way to catch these errors before they cause a disaster. This lets you handle the problem gracefully, maybe pop up a friendly message, and keep the whole application from falling apart.
And these keywords right here, this is your toolkit for doing just that. The big ones you'll use all the time are try and catch. It's pretty simple, really. You put any code that might fail inside a try block. It's like saying, hey, Java, try to do this, but be careful. Then, right after it, you have a catch block that says, okay, if that thing failed, here's what we're going to do about it. It's your safety net. It's how you build programs that don't just give up when something goes wrong. Okay, now we're getting into some really advanced stuff. This is a new level of mastery. We're talking about making your program do multiple things at the same time. This is an absolute game changer for modern software, and it's a built-in superpower of Java called multithreading. I love this analogy. Think of a master chef in a busy kitchen. They're not just doing one thing at a time, right? They're chopping vegetables while something is simmering on the stove and another dish is in the oven. That's multithreading. It's what keeps your apps feeling responsive. You know when you click something and the whole app freezes? That's what happens without multithreading. With it, one part of your program can be doing a slow download in the background, while another part is still letting you scroll and click around. It is absolutely crucial for a good user experience.
And check this out. This is what it looks like in action. This is the output from a program running 3 different threads named 1, 2, and 3. They're all just counting down from 5. But look at how the output is all mixed up. See? 1, 5, 2, 5, 3, 5, then 1, 4, 2, 4. That's because the computer's CPU is switching between them so incredibly fast that it looks like they're all running at the exact same time. That's concurrency. So you've made it. You've faced the challenges. You've unlocked these incredible new powers. You've gone all the way from the absolute basics to these really complex ideas like concurrency. So what's the payoff? What's the ultimate reward for completing this quest? Let's take a look at the actual skills you walk away with. The reward is a seriously powerful new skill set. You're not just someone who can read code anymore. No, you're now equipped to design, to build, and to solve really complex problems. What you're seeing here might look like just a list of course outcomes, but what it really is, it's proof that you now have the tools to take an idea out of your head and bring it to life with code.
And this is not just abstract theory, okay? This is the kind of stuff you'll actually be able to build. You'll be able to develop things like a stat class to manage data. You'll be able to model real-world things like an employee with their own unique information. You can create a MyPoint class to work with 2D graphics. You can build out that whole shape hierarchy we talked about. You'll be turning these big ideas into real working code.
So there you have it. The path is all laid out. All these fundamental powers are just waiting for you to unlock them. And you know, this journey, it really does transform you. You go from being someone who just uses technology to someone who can create it. So the only question I have left for you is, are you ready to start your adventure?